Okay, so as I said, today's topic is finding C++11 references across your entire project. This week, we are focusing on language-specific topics. So today we're talking about C++, and Thursday we'll be doing a Delphi-specific language skill sprint. So today's topic is about reference finding. As a reminder, skill sprints are meant to be a quick webinar. The idea is that you walk away with a skill. And so that's today's skill, as we talked about, is how to enable reference finding, definition finding, and these new features for our C++11 based compilers to get you up and running with that immediately. Afterward, we'll be happy to take any live questions and answers that you might have. So in the meantime, feel free to enter those into the questions panel in the GoToWebinar panel. Finding C++ references is a term that we use to reference, well, pun not intended, actually, code browsing features. And code browsing can include many different things. In particular, this release supports C++11 language. And what that means is we're using a highly compliant compiler front end to enable these code browsing features. This is a new indexer. It's based on the Clang front end that today we support the 64-bit Windows platform, the iOS platform, and the Android platform with that front end compiler. And so this indexer basically indexes using that front end to deliver the features such as finding definitions, finding references, looking at hierarchy information, whether it's a base type or derived type or the whole hierarchy, jumping to a type declaration, and also analyzing any header dependencies. And as we know, as C and C++ developers, header dependencies are important to understand and to optimize as well. Before we get into the demonstration, I want to talk a little bit about this architecture that is based on this highly compliant Clang front end. And this is what we call the language engine. So Embarcadero is utilizing the Clang front end and bringing to it the secret sauce that makes C++ Builder and app method C++ really shine. And in particular, that's delivered with a couple of key language features and support that's added to this front end. In particular, our PME extensions, short for property, method, and event, and includes things like support for closures, support for properties, etc., as well as RTTI, or runtime type identification, and that's a rich set of dynamic information to allow dynamic invocation and discovery of objects in your code, and to be able to work with them without having intimate knowledge through a typical compilation cycle. So these are key features that drive this rapid application development cycle, being able to do visual design and code with these features as well. This language engine, because of our extensions, supports the compatibility with Borland C++, with C++ Builder, as well as the Clang front end itself, which is a highly compliant to many of the standards, including C99, C++98, and C++11. And because of that, we can support these typical libraries that you would use in C++, including, of course, the standard template library, libraries like Boost, Loki, and Ace as well. So this front end is used to compile your code to a intermediate representation known as the LLVM-IR, and then that LLVM-IR is run through the LLVM backend for code gen, and we can code gen Intel instructions, both 32-bit and 64-bit, as well as ARM instructions targeting iOS and Android devices. Targeting is specific, the ARM v7 architecture. So this part here, where we talk about the language engine, this is also where the indexer lives that we're going to talk about today. It uses this language engine, but the indexer basically indexes the project, stores that information in a local database, and uses that to drive the feature. So there's a cost initially with creating the index, and then it gets updated each time you save a file. So that's the basic architecture that drives the whole tool chain all the way to deploying on a particular device, whether it's based on Intel or ARM, as well as features like this find references using this, this language engine based on Clang. Okay, so now let's jump into a quick demonstration. So in the IDE here, let's go ahead and create a new VCL application with C++ Builder. Sorry, I can't seem to use my mouse very well right now. And what we get is our standard source files to support our form, and that includes a header and a source file. So the header has the basic setup for a derived T-form class, and in the definition file we have our constructor. So just to show you how the features work, we'll work with this really basic example to start with. So the first thing you have to do is you need to enable the indexer. So that's found in project options, and it is actually found down here in the project properties. So by turning on the index files for definitions and references, we will kick off that indexing process so that we can find all the symbols in our code and in any of the include files that we have included as well. While I'm here, I want to point out another feature in XE6, which I'm not sure if many of you are aware, but we've added a switch for each project so that, especially for large projects that could run out of memory if they're very large and you're loading a lot of files into memory, in particular the linking stage, you can run the toolchain or the compilation process outside of the IDE. And so this will give the compilation process the full amount of memory available to it to run that process. Whereas if you don't use this option, the compilation process will share memory with the IDE. So they're all sharing that 4 gigabyte amount of memory. So now that we've set up indexing, you need to enable 64-bit Windows. So now that I have 64-bit Windows enabled the indexing, you can see the indexing is kicking off. So just a note, 32-bit indexing is on by default. 64-bit indexing is not. So once you add the 64-bit platform, you want to go ahead and select that indexing option and let the indexer work against the project using the 64-bit Windows compiler that we were talking about. And once that indexing is done, now we can take a look under View, and we can see under Find the key types of reference or definition discovery that we can do. And so in particular, right now we support finding references, finding definitions, header dependency viewing, as well as type hierarchy. Let's go ahead and you can, well, first of all, or second of all, you can also find it here in the context menu. So let's go ahead and find a definition. So we'll pop back to the header file, and we'll take a look at our T-form1, and we'll say find definition for the constructor. And that, of course, takes us to the source file with that definition. So now let's take a look at T-form1, and let's find any references. So we should find several references in the project. So you can see form1 is used in project 1 to auto-generate the form. You can see that in the source file we're creating a pointer to our T-form class. And you can also see a reference to it in the constructor, and back in the header file you can see it in the class declaration as well as the extern statement so that it can be accessible from other files. So now that we found references and we already were able to find the definition, let's take a look at header dependencies. This is a pretty small project, but it, as you can see, pulls in quite a few headers. And so this allows you to really see which headers, and in this case this is a bunch of Windows headers, are being pulled in to support Windows development. And if you double click on any of these, it takes you, of course, directly to the file in question as well. And then lastly, let's take a look at the hierarchy of our T-form. And so we see that our T-form1 is inherited from a VCL forms T-form type, which itself is inherited from T-custom form, so on and so forth. So this is a good way to understand the full hierarchy of the application you're working with. Just as a reference, let's go ahead and build a new mobile C++ application. Because this is mobile, the compiler for this is already supported, meaning we don't have to enable 64-bit Windows in this case. So this is a FireMonkey-based project, and what we'll see in this one is a different hierarchy, a type hierarchy, versus a VCL form and a FireMonkey form. So let's go ahead and let it finish indexing here, and let's ask it to show us the hierarchy of our T-form 1. So this is our FireMonkey version of T-form 1. It derives from FireMonkey form, which derives from T-custom form, so on and so forth down the line to finally the base object, which is C object, compared to the VCL hierarchy here. So that was a simple example. Let's open up a C++ project that is pure C++ and uses, for example, the standard template library, as well as the Boost open source library. So in this one, we see a bunch of code written that uses quite a bit of C++ libraries. So you see a lot of C++ header files here. So let's first take a look at the header dependency that we have. So I've asked to show me the header dependency of IOStream, because that's what I was pointing on, and these are the headers that it pulls in to support streaming. So you can see even down to the C libraries that it depends on. Let's now take a look at something like, here's a type called bus schedule. And so let's go take a look at its declaration. There it is. So there's bus schedule, and it's actually, since it's using templates, it's being done right here in the file here. We'll go back to main unit H. So these are the types of that we have, GPS position. And so let's go take a look at the GPS position definition. And so in that case, there are no definitions available because it's done as a template class with a definition done right there in place. And now let's take a look at something like a C++ object that is deep in the hierarchy. Let's look for something like standard cout. So again, we can go find its definition or its references or its type hierarchy. Let's take a look. We'll do that on something like standard string. So here's standard string, and here are the classes that it derives from. And another good one to look at is something like ostream, because then we can also take a look at what it would appear like if there was something like using multiple inheritance. So let's take a look at ostream here. And so here's a situation where it's got multiple inheritance going on. Okay, so that was a quick skill about how to enable C++ fine definition reference hierarchy and dependency or include dependencies using the 64-bit Windows compiler as well as the mobile compilers for Android and iOS. You can find some product documentation on our doc wiki. So here's some examples of the page for definitions and references. And another page you might be interested in visiting is what C++11 features we support. So thank you for joining today's skill sprint, and I'd like to open it up to any Q&A that you might have. So the question here, first one is, how does 64-bit or 32-bit come into indexing? And generally, there isn't a difference in terms of indexing. They're just symbols in a tree. As I was mentioning in the third slide, we're moving to a Clang-based toolchain, and that toolchain has different language support as well as a completely different front end. So the addition in this version has been to add support for these types of code browsing features using that Clang-based compiler. The Clang-based compiler supports 64-bit Windows. The previous compiler is 32-bit Windows, so that's where the difference comes in. That's why I had to select 64-bit in order to kick off that indexing to use that new front end. If I was doing a mobile project which already supports that front end, then you didn't need to do anything other than turn on the indexing. So I hope that explains why that happened. The other question is, can the Boost libraries be easily built by checking out the latest distribution at boost.org or building for C++ Builder? Sure, you can do that. We do actually we do provide a version of Boost in Boost libraries. So we do testing for you. But absolutely, you can pull Boost libraries and try them out and build them with C++ Builder as well. So that is definitely an option for you. Next question is, how current is the version of Clang being used by C++ Builder for Win64? Today we're based on Clang 3.1, which was the first to support C++ 11, and I recommend checking out the page where there is talk about the C++ 11 support. So we're working on moving that up to Clang 3.3, which will give us the full support there. And the question is about C++. The next follow-on question is about C++ 14 support, which isn't fully defined yet by the standards committee. They're working on finalizing that. You'll see it in an upcoming version of Clang. The big feature was supposed to be Concepts Lite, but I'm not so sure if that's going to be in that spec yet. So we're keeping our eye on that, and we'll be moving to that version of Clang depending on the features that are supported there as well. So I see a question here, when do you want to use this feature? Well, this kind of feature is really useful for a couple of reasons. One is you may be, especially for very large projects, you may want to find all the references to a particular symbol and understand where they're coming in, how they're being used. So that's where basically the find references comes in handy. The one that I think is particularly useful is the find definition. So let's say you're using a class that you brought in from a library, and you're not quite sure what it can do. If you go to find definition, you'll see the definition of the class. You can go to its declaration, and you can basically see its interface and find out what that class or object is capable of doing. The other two, which are type hierarchy, that allows you to quickly see what its inheritance chain is. So again, that's useful if you want to try to see what you can access in its ancestors, for example. And lastly, the header, its header dependencies or include dependencies. So that's always important, understanding your include dependencies, because it affects circular references. It affects so that would affect potential compile issues. Also, it can affect compile time. So it's a strategy around precompiled headers. This will give you a really good view as to what it is that you're actually pulling in and where it's getting pulled into the compile cycle.
So is this only available on 64-bit Windows, or is it also available for 32-bit Windows?
Now, 32-bit Windows has its own code browsing features that are different. The ones that I shared today are new code browsing features that are built on the new toolchain. So the ones that I showed you today are available on the Clang-based toolchains, which are 64-bit Windows, iOS, and Android. Most of these features also exist in the 32-bit toolchain as well today. So if you switch to 32-bit version of your build, then yes, you'll be able to see those.
Okay. Are there chances that this indexing will be implemented for Delphi as well?
Well, Delphi already has some code browsing features which uses an indexer as well as a live AST. So that already exists today.
I don't see this available in 32-bit Windows. Where do I find it?
So what you do in 32-bit Windows is you don't have to turn on the indexer in 32-bit Windows. So that's one difference. It's already running. And then you basically, in your 32-bit Windows target, once you selected that platform, you'll see a view option for the various browsing features, which will open up the code browser. And in there, you'll see many, and there's actually a few more available in 32-bit Windows as well that you'll be able to find.
Will C++ Builder X11 features be available, or when will they be available for Win32?
We are working on that, but we have not announced a release date for that yet.
I saw the option to let the compiler compile on a separate thread. Can this also be done on the Delphi compiler?
Yes, it can. So both the Delphi compiler and C++ Builder have that switch that allows or tells the IDE to shell out the build process into a separate process. It's not a separate thread, it's a completely separate process. So it does get its own process space. And that'll be really useful if you're running into or out of memory, for example, building large projects where you're sharing that process space with the IDE.
Great. Thank you, JT.
Thanks. Bye.